Today we're talking about a deeper level of your servo roll feed, the motion controller and the servo motor and the amplifier, and how all of that works. So to start off, you have your plant power going into your drive amplifier. You have your press signals going to your motion controller. You have your servo motor. You have your feed rollers that are connected by this Kevlar belt, timing belt that Coil had pioneered in the 80s. So how does all of this work? The big question is that the amplifier has all this power to it, but how does it get to your servo motor? How does that translate into distance? And how do we repeat that over and over again? To start off, the press sends a signal to your motion controller. Power is on the drive amplifier, and your motion controller can control the speed and position, meaning it can command the speed and position. So it'll say, hey, I want you to move this distance at this speed and this acceleration in this amount of time. And it sends that signal to your drive amplifier. That drive amplifier interprets that and says, okay, I need about this much power to have that motor hit this requirement. And it sends that motor power in and gets velocity feedback and will trim the amount of power it's giving it in order to accomplish what it's being commanded to do. So how does the servo motor work? Inside of your servo motor is what's called an encoder. Now, I'm sure in the industry you've heard of encoders, you've heard of resolvers. What is an encoder? What is a resolver? An encoder is a multi-point positioning device that, as it turns, will tell you a very high resolution. Different encoders have different resolutions, but a very high resolution of what exact position that has been moved into. There are things called absolute encoders. There are things called Ethernet encoders. There are things that are called resolvers. Now, resolver is essentially a lower resolution encoder. So just so you know, if you ever hear those words, don't get confused. They all have different meanings and they all do different things, but really they hit what is the current position within the accuracy of that device, right? In rotation. So that's how it measures, is in rotation. So as this rotates, that'll turn your pulley. Your pulley turns your lower feed roll, and it's coupled by a gear to your upper feed roll, and will also turn that so that they move the exact same position as it's commanded every single time. So essentially that's exactly what's going on. You have your motor coupled with an encoder, you have the motion controller, it's called servo motor, you have position, speed signal coming in, you have your press signals, which we've already discussed, which is when it wants to feed, when it wants to pilot. You have the plant AC power coming in, and all of this gets put together and commands this servo motor to do exactly what we need every single time and hit the performance specs that we promised you on your quotes or whatever version of machine you have in your facility.